I'm gonna, apparently it's on this vast topic, but I'll try to keep it simple. So just by show of hands, who's here and has just heard about Rust but never coded in Rust and is interested in maybe looking at it? Yeah. Who did a bit of coding in Rust but doesn't, and who's actually working with it daily or considers themselves good?
Jedi
Nice.
Master here. There you go.
Okay, just to get an idea of the audience. So I myself, I'm pretty new to Rust, a few months now, less than a year. Just on my background, so most of my life I was in research, theoretical physics, then transitioned more and more towards engineering. And for the last few years, I was leading a company where we were building a SaaS business with simulation, so we needed very high performance programming. Unfortunately, we chose C++ back then because that's what I knew. And at the moment, I'm working on kind of a new open source version of Databricks library written in Rust, but for Python, which is, I hope to open source at some point in the next year or so. So that's kind of from my perspective of where I'm coming from, and I maybe want to give an overview of for whom is Rust useful and for whom not, and what are the critical parts. So when we're working in a software development team and you're working with a complicated project, then over time your code base grows, right? And which tool do you use for the task, that is of critical importance very often, right? So I look at programming language from different perspectives. One critical one is what is the tooling and the library quality like, right? Because you don't want to rewrite a whole lot of things yourself, and you want the stuff to kind of just work, right? So rating different languages, rating different languages, so those are kind of the languages we chose, except for Rust. But I think that shows my preference in terms of if you want, Rust is really one of the libraries with the best tooling out there and the highest quality of libraries. Before I would have thought that it's maybe Python is good before we really started using it, but I felt on average the quality of libraries is a lot lower. And the second axis is up here is performance. So obviously Rust is kind of on the same level as C++, but we're also using Julia very heavily. The other perspective is iteration speed. How fast can you get moving? How fast can you get quickly stuff done, which is critical here in a startup. But then as the code base grows over years, at some point, we're using Python and TypeScript a lot. At some point, it kind of you get a lot of errors and you get a lot of problems because somebody changes something and you have these long range effects, right? And I think that is another place where Rust kind of really can shine, and that's why I'm pretty optimistic and bullish on this language. So those are my preferences. I wouldn't say you should use Rust for every single project. So what I want to go through tonight is kind of the high-level ideas of polymorphism, because if you're coming from me from C++, there are also different approaches to do that. And very often, you want to solve problem X. Which high-level approach? There are multiple ways to do things. How do I actively know which questions to ask and which ones to choose? Because if you make the wrong choice, and this is true for us as well, it's going to bite you very hard later on. Right? With stuff not working out and the code, it does work, but the weight on your shoulders kind of just grows. So coming from normal languages like, I guess, JavaScript or Python or C++, we often have the object-oriented mindset of how you do polymorphism. You have objects, and you attach methods to the objects because it sounds like a good idea initially. Why not? And in Rust, you actually take a very different approach. So Rust has a much more minimalistic set. You have two different types. You have enums and structs. And on the other hand, you have your methods separate, right? So you break it down into much, much smaller parts, and then you look at how can you compose these together with traits for much more powerful methods in one approach. So a large part of learning Rust is actually unlearning previous knowledge, right? So whereas in OO, you often, you attach the two things, and that kind of really also slows you down with iteration speed. Where I feel Rust is still a bit slow or shortcoming is, I really love the fast iteration speed of Python or JS, and you immediately see the results. And in Rust, you always have, if it's a big project, they compile for 20, 30 seconds, and that kind of really breaks the flow. So the spot up there is actually what I'm working on. I want the stability and the speed of Rust and the features, but I also want the immediate feedback and this way of seeing your data live, and hot reloading, etc. So the thing that we were optimizing for with a big code base after a while was okay, a lot of your time, you're just spending debugging things, right? And how do you measure code quality? I think this kind of captures my feelings pretty well. It's like, if it's understandable and a new developer or anybody else or myself can dive in a year later and I can figure out what's going on, that is good, right? Anything, if it takes too long and a smart person is trained in it, if it takes too long, that's a bad sign, right? So I think that is a good optimization metric to go for. And I think that is the perspective one should also take for programming languages or for approaches to problems to evaluate which decision is better at a given point. Because otherwise you just have like religious debates about preferences all the time. So with unlearning in Rust, if you come from OO, I would say if you attach your methods and you have a whole mindset in there, essentially you have very little flexibility, and at some point it really bites you, right? So in OO, the ideology kind of at some point dispatches you and drives you crazy. And I think it is one of these parts of Rust that really helps. So what is the equivalent pattern in Rust, and how can you do things here? So I think we already, in the previous talk with pattern matching, we came across enums, but these are really the two fundamental mathematically distinct types that you can have, right? The struct is often also called the product type. Why is it a product type? Because the number of states you can have is the product of the individual states of the subfields, right? So if you have a struct like for different foods like laksa, and spiciness can have like 256 states, that would have 256 states itself. If it had a bool, that would be times 2. Whereas an enum is a sum type, and that means you have either A or B or C. And that is a very powerful method or mechanism to model domains. I mean, that's not unique to Rust, that's just generally in any domain model. So we can, in Rust, you can do polymorphism in basically 2 big directions. The first one is with enums, and the second one is with traits and generics. Right? So we'll go through the simple one first, which is polymorphism with enums. So it may come as a surprise. Everybody knows that for structs you can overload methods. In OO, you would just define a method on the class, and that's what you can call with dot something. In Rust, you can actually you can also implement methods that directly for enums themselves, right? So if food is an enum, which was the one from before, right? Like that's the enum between these 2 types. You can also just say impl food, which is the equivalent of attaching methods to a class, right? But you can also do that for enums here. So you get all the power, and they treat it really on equal footing. In that case, internally, if you have an enum, you have one of these 3 options. So you have to, I mean, you could return whatever string you have or whatever conditional between them as well, or depending on some external state. But very often, if you have an enum, of course, the typical thing you'll do is snatching, and then maybe some post-processing. Right? But that you can just attach the method to that, and if you have multiple enums or multiple different types, that is polymorphism kind of by just explicitly writing it out, right? It's not very succinct, but that's, I would say, stage 1 of getting polymorphic. You can also have functions, since enums are first-class citizens. You can also just have functions. In this case, it returns an option of the enum, right? Like there's nothing special about that. The question now, suppose we want to return a vector of the different kinds of food, right? So we may have 3 types of food, which is laksa, chili crab, and durian. So, and we want to create a function that maybe takes, if we give it the strings of that, like strings that encode that, and we want to return that into type data, right? And we also want to, if you give it something that is not in the list, then it should return, the previous function would return a none, and those we want to filter out, right? So it's very succinct in Rust to do that. So we say make meals, we just transform the original ingredients into an iterator, what we saw before. Then you can have a convenient function filter map, which will take, if it's a sum in there, sum of a food, it's going to apply the enclosure that is in there, and it's going to apply the ingredients. And if it's none, it's just going to filter it out, right? And then at the end, it's going to connect that. So this makes polymorphism with enums kind of almost trivial, and you don't need to think about lifetimes, you don't need to think about any of these problems that come up, or generics with how your compile times explode. So unless you have a good reason to go with generics and you're modeling a simple domain, I would say stick with enums, and especially at the beginning, that's a much safer way to go. than using generic functions. Suppose we have a function now that actually takes an arbitrary food and returns something, right? And we want to aggregate over that. So, for instance, if we have the meals from before, which is the vector, we could just iterate over the vector as we learned before, and now we can map the function calories, which takes that, and we can call sum off. Right? So depending, it doesn't matter which kind is in the vector, which kind of food is in there. This is automatically going to dispatch to the right function. Right? So that's one form, or that is polymorphism with enums in a nutshell. I think it looks almost too trivial to be interesting, but this is a pattern that if you use it, it's just kind of foolproof. Any questions so far? Okay. So suppose now we have so also for combining these functions, that's just one more function where you could take a reference to food and return a string. So nothing like before, just pattern matching. And you can, depending on the case of the enum that you have in there, obviously you can, as we've done before, you can take, if it has an internal parameter, you can access that inside that case, right? And that's how you can split up your code and actually make it very readable, that the structure of the code reflects the structure of your data, which in my opinion makes it very visible. Of course, if you see the structure of the data before, maybe described in docs or written somewhere, then you'll very quickly catch up with that. Let's consider what the memory layout looks like if you're using enums. Then if you have a vector of that, your actual vector will just be 3 pointers. It'll be one to the beginning of the vector, then to the where the last element is, and then to the end of the allocated space, right? So you'll do like you only need to do one pointer dereference if you're using a vector of these enums. And the compiler will actually, depending on the number of cases you have, it'll pack typically 1 byte or whichever number of bytes it needs as a marking flag of which case you have. So if it's actually fairly performant, you do need to do compile time, runtime checks, which case it is, but that if it's predictable, like the CPU, the prediction system will kind of catch that fairly well. And these things are, because they're next to each other in memory, the byte which determines which type it is also in the cache already, so that's essentially for free to look up under most circumstances. So let's move on to using generics and trait bounds polymorphism. So in C++, if you're using generics, it's extremely powerful. Template metaprogramming is kind of a full functional language. You can do whatever you want. If you get it right, it feels like that. But most of the time for myself, it's like if you're doing too much of that, that's how I felt. And it's really hard to debug. Rust has a much more restrictive approach, right? Like it's going to not allow you to do as much in generic functions, so I would argue for is a very good thing. Let's say I have a general generic function of the type T which returns a string. If you don't say what T is, or you have no constraints on it, you can't actually do much for T. You can maybe get its address, but like if you're writing normal safe Rust, that doesn't help you a lot, right? So it kind of feels like, okay, you've got this thing, what am I going to do with it then? Right? Whereas in C++, you can just you can call methods and if that implements it somewhere, that'll go through. So that's where traits come. So what is a trait? I think of a trait as an interface. So you're actually decoupling the concept of what a type has to fulfill. And then you're saying, like, if this type fulfills the trait, edible in this case, I guarantee it's going to have calories and spiciness level. And if I provide a new type as a user of the library, I can implement that trait, which means I'm providing you this functionality, and then the other side can assume that it is there, right? So it's really decoupling this approach in there. So we can implement the edible type for our three struct types from before, and we just implement the functions individually for them, right? So all of them fulfill the edible type now. And the other big thing is that traits in Rust are first-class citizens. I think that is different from many other languages, which means you can, for instance, say, I can import a trait, edible, into my namespace. And it's a first-class thing, and different people can implement different traits, and the names of the methods can even overlap and clash. And you as the caller of the trait, you can choose which one you use, right? Which is massive, because in Python you often need to do, if you do monkey patching, or it gets really dirty. Whereas in Rust, it allows for much more local reasoning, because you get to decide you can restrict your traits and the methods that you have access to, which ones you're using, on a much more local level. So this enhances the reuse of data structures. You can also, like, if you look at the scope, what is in there, because you can actively only import what you need, reduces that pollution. Naming collisions, which in big projects, if you're using libraries and everybody's monkey patching, those can be terrible to debug, not an issue in Rust. And that massively increases local reason. So I think this by itself is, if you have massive code bases, this is one of the biggest features that Rust provides in terms of separating data and the methods on that, and that you can control both of them which you're using, and you can actually reuse the structs to a much bigger extent. So you're really making the methods and the traits themselves a first-class entity, right? And you make them a thing that you can talk about. That's important. Once you define a trait, you can also use it as a trait bound. So I can describe a generic function now. I can say, this is a function that's going to operate on any type T that implements edible, right? And now within that function, I can actually use all of the methods, and only the methods that are allowed, which are guaranteed to be provided by the trait, right? So this code can assume that this is there because the other side provided that. There are two other ways to write that. Like the short form on top is, instead of putting the trait parameter in there, you can also just say import editable. And before we also saw that in the other traits with the where. You can also write it out fully with where, and if you have a lot of different constraints, obviously you can split it up over multiple lines, you can make it much cleaner. What is that? So generics and trait bounds really go hand in hand. The trait bounds give the restrictions on what the possible types can be, and in a very readable form, and constrain. So it's really like, I think a bit like Batman and Robin, those two things together. You can also combine traits. So you can, for instance, it's even useful to define empty traits. You can define a trait edible with beer, and we're not going to implement that for durian, only for laksa and chili crab, right? And you can even say, like in this case, edible with beer requires the trait edible already, right? Like you can't have something that's edible with beer if it's not edible, right? So you can even say this trait only makes sense if these other constraints are given. And then even with the default implementations of the trait, I could access methods of the other trait, which allows for even more generic and powerful code there. So with this, you can now also add multiple trait bounds. Like let's say I want to write a function indulge only for things that are edible and edible with beer, right? So that's how I can combine these traits. I can add plus, or if I write the multiple lines, I can just split them into multiple lines. The last thing we want to come to is trait objects. So like we put the structs of enums, the enums into a vector before, you can actually also do that if you're using generics and traits, but it's more complicated. So that's where you need to use dynamic dispatch in Rust. So that's where you see if we define a data structure meals on the fly, and we want to say if the meals vector can contain different types. It can contain either durian or chili crab or laksa. I actually need to put it into a box. And why is that the case? Well, the compiler needs to, it doesn't have that information at runtime which one it is, right? So it needs to, like the box, and they can be of different size. So the different size issue is solved by box because that's going to be hidden out of edit somewhere else. And like a little flag can be stored in the actual pointer. So you need somewhat of a more verbose syntax, but then the using syntax from before, like that is pretty much like before. So you can just iterate over food and meals, and now you can call all the trait methods that are available, but nothing else, right? So you can, Rust forces you to only use whatever is provided and safe and guaranteed to be safe to use. So how does that look in memory? So there will be a vector pointing to like the actual vector data structure, like before, pointing to the beginning of the vector. The vector itself will actually be like these box objects, which are two pointers. The first pointer is to the actual object on the heap, and the second pointer will actually go to a V table. Right? That is where the type information is stored. And the V table, this will, depending on the type that it has, that will know which actual method or function to dispatch to. Right? If you look at your executable, the function for each different type will be baked in somewhere. But this actually means to execute one function here, or one method, you need to do 4 pointer dereferences, right? So if it's any critical part of code, this is going to be so much slower even than enums, right? Like and it's way more complex. So if you can ever avoid this, like it's definitely worth avoiding, but it's very useful if you definitely need to, because for other reasons you've been doing things with generics, and you need this hatch to get out in some places, right? So see this as a matter of last resort, because things are a bit so when to use enums and when to use them as generics. I would say enums is, you as the implementer of the enum, you provide a finite list and it cannot be extended by the user, right? Like whatever is defined in the enum list, that's all there is. If the user wants to extend it, they need to change that source code, right? So it's not extensible by the user. And if you want that to be the case, then that is a good choice. Whereas traits, using traits, I define a trait and anybody else in the future can define their own struct. And now they can implement this trait forward, right? So that means user extensibility from the get-go. The second one is runtime polymorphism versus compile time polymorphism. So enums are runtime polymorphic. The type is stored in the flag under normal circumstances. And whereas for traits and generics, unless you're doing the dynamic dispatch, the specific type at each point is known at compile time, which also means that the compiler can optimize and inline the code, and that can be massively faster than for enums. It's usually not the checking of the flag that's the problem, because that's how they cache. It's that that the compiler can cross-optimize across these function call boundaries. Right? Enums are way easier to use. I would say traits are harder to use, but you should definitely learn using traits, because in Rust, like, it is one of the very powerful tools. But as you become more advanced in it, that is definitely that makes certain things a lot easier. But using them with generics gets a lot harder, right? For us also, like, compile times are always an issue for myself. Like, if you're using a lot of generics, the compiler instantiates functions for each specific type, and that means if you have an explosion of different instantiation types, your compilation time can go out of the window very quickly, right? So it's really a trade-off between like performance and like binary size, etc. Yeah, so with that, hope this is some advice from our own few months with Rust of like how can you keep your code flexible and make the right choice initially on which mechanism to use.
Thank you. That looks like a GPT generated image.
That's correct.
There you go. Thank you so much. Any questions? Question?
Yeah. Do you know anything about phantom types, phantom markers and all this?
I've read up on them a while back, but I'm really not an expert.
Okay.
Yeah.
Thank you.
For testing, traits often allow you to provide a mark, right, or provide a stub, which I think would be more difficult with an enum. Is that right?
Could you give an example? For
you've got some business logic, and it says, okay, I want to accept the implementation,
right?
And if it accepts a enum, then you're stuck with that enum. You can't pass in a stub instead. While if it accepts a trait, you could provide a stub which says, okay, just return whatever string, right, instead of doing real logic.
That's a good point, but I would say you can, like, if you're providing a stub, you're probably also only testing one path, right? So isn't that the similar amount of code coverage or like path coverage as if you give one complete enum case where you just were to put it in?
I'm worried more about not having to use expensive infrastructure in a way.
Right. Like, I think the one thing that you can do is, like, once you're going with generics and traits, it's a lot more about information known at compile time, and you can make constraints into the type system which are inherently true, because like otherwise it wouldn't even compile, right? So like I would think in terms of like that is, I think, maybe one major advantage, and maybe it ties into what you meant, where like if you can make use of the type system that some complexity of business logic can actually code in that, right? Then you don't need to cover it with text, because you're kind of leveraging the proving of the compiler. Yeah.
Thanks.
And I check very quickly while people are waiting. If you want, go to menti.com, put that code in. If you attended my previous session, we're going to learn more by playing a game. 5 questions only. and we're going to see if you pay attention, okay? Now, I'm going to go to question. But if you're waiting, you can just join. Go to menti.com, use that code in, and join. Again, the disclaimer, if your mobile